Hello all, this is the lecture series number 09 of Haloalkane and Haloarenes. Okay, this we are continuing 12th standard chemistry based on NCERT, and we are providing over here 100% free notes as well as 100% free concepts. So you can get it through here, right? So to continue, this is the lecture number 9 for haloalkanes and haloarenes. So we have completed till SN1 SN2 reaction, means nucleophilic substitution reaction. I hope you have revised those topics. If not so, you can go to the playlist and you can watch all the videos, and then you directly come to the lecture number 9 and you continue your classes. Okay, so today we are going to discuss the elimination reaction. Okay, so elimination reaction. So to easily identify whether the reaction is elimination or not, you have to just look into that. If suppose your starting material is the carbon is having sp3, your product should be sp2 or sp. If the hybridization is changing from starting material to the final product, and that is from sp3 to sp2 or sp, then you say it is elimination reaction. If suppose your starting material is sp3 and your product is also sp3, then that will be your substitution reaction, correct? If your starting material is sp2, sp and your product is sp3, then you say your reaction is addition reaction, correct? So now see this, we will again, I'll let you know when I'll write the reaction, that time I'll make you understand, okay, that how we are looking this from sp3 to whether it is converting from sp3 to sp2 or not. Okay, that we will see it. So just in a single point we can say if it is converting from sp3 to sp2 or sp, then your reaction will be elimination reaction, correct? So suppose here carbon is there, correct, hydrogen, and then single bond, again one carbon, okay, and here you have one living group. You should have one living group, correct? Now what is happening, see, if you are providing, if your reaction contain base, so what this base will do, it will take this proton and then this bond will shift over here. As soon as this bond will shift over here, this carbon will feel that I am having 5 valency, then immediately this halogen will go with this bonded pair of electron, right? So here it will be minus H, this hydrogen, because it will go out as a H plus. So this H plus and this X minus, it will be HX, or means hydrogen halide. And what you are going to get it? You will get your product double bond, correct? So now you see this carbon we have sp3, correct? Now your product, this carbon is sp2, correct? Even this carbon is also sp2. Here this carbon is also sp3. So we are moving from sp3 to sp2. As I told you, if your reaction is from sp3 to sp2, simply you say this is a elimination reaction, correct? Now see, there is not a single type of elimination reaction. We can categorize this elimination reaction up to 3 different types based on the reagents and starting material. So that can be E1, that can be E2, and that can be E1CB. Correct? So E1, E2, and E1CB. So like that category we can classify based on the reagent we have added, whether it is a acid catalyzed reaction or base catalyzed reaction, or maybe we having any electron withdrawing group in the reactant molecule. So it will be fully depend on your reagent as well as your starting material. So based on that we will classify. So here we are going to discuss all the three. What, like when we say that it is E1, E2 and E1CB. So this mechanism you should know it. Okay. So before going that, just we will write it down. Okay, what is elimination reaction? So just write it down. As I told you, I will provide you the notes also. So I should give the notes. So just write it down. When a haloalkane with beta hydrogen, okay, beta hydrogen atom is heated with alcoholic solution of potassium hydroxide, okay, there is elimination, okay, elimination of hydrogen atom from beta carbon and a halogen, okay, and a halogen atom from the alpha carbon atom. And you just write down that reaction which I told you. Here's the simple carbon, okay, hydrogen over here, and you put the leaving group over here. Simply base we have, it is taking this proton, this bond will move, this will go along with the negative charge, and what you are getting? You are getting carbon double bond carbon here. It can be anything, hydrogen or any other thing, whatever you want, it will be, and then you have HX, okay, hydrogen halide, correct? And base it will be take out because it's a catalyst. So base will be as a catalyst, it will be go out, correct? So this we call is beta elimination also. This reaction we call it beta elimination also. Why beta elimination? Because beta hydrogen is helping to remove and to process this elimination reaction. So beta elimination, we know it a beta elimination, okay. Now first we will discuss all the three type of E1, E2 and E1CB, and then we will move, we'll write some of the points, okay. So first let us see, here I have written that alcoholic solution of potassium hydroxide. So you have to understand what is alcoholic solution of potassium hydroxide, okay. See, if you are taking a reaction, suppose this is the reaction CH3, CH2 and Br. Now suppose if you are taking aqueous KOH and if you are taking alcoholic KOH. See here what we have taken, alcoholic solution of potassium hydroxide. The same thing, alcoholic KOH, here aqueous KOH. See here it is alcoholic, here it is aqueous KOH. Now if I am reacting with aqueous KOH, what product we are getting? We are getting CH3, CH2, OH. If we are reacting with alcoholic KOH, what product we are getting? We are getting CH2 double bond CH2. See how? Only with aqueous and alcoholic, okay? If we are changing, we are getting this product. So no need to mug it up. We have the mechanism here. How this alcoholic KOH is giving alkene and aqueous KOH is giving your alcohol, correct? See, in aqueous KOH, the reagent which is attacking over here, it will be OH minus, correct? Because aqueous KOH, when the KOH is dissolving in water, it will be K plus and plus OH minus. So this OH minus is doing, it is processing the SN2 mechanism, okay. As soon as it will attack over here, this bromine will go out, right? So see, this OH is coming over here and this bromine is going out, and with K it will be KBr, okay. We can write KBr. But in this case, what is happening? So I'll just change the color over here. So see, in alcoholic KOH, this alcoholic, it is C2H5OH, correct? And plus we have KOH, and that KOH, little bit of water we are dissolving this KOH, so it will be again KOH. So now what will happen? Here it is K plus and OH minus. So after reacting these two, it will form C2H5O minus and K plus as well as water. See, OH, this hydrogen and this OH. So this hydrogen and this OH will form water, and this K plus and O minus. So this is this, what is the name of this? It is your potassium ethoxide. And you know that this one is a stronger base than your OH minus, correct? So potassium ethoxide. Now it will act as a base, not as a nucleophile. But here in this case, this OH minus is acting as a nucleophile, correct? One more thing we know that if your if the size of this species is less, then it will act as a nucleophile. If the size of this species is large, then it will act as a base. This is the comparison, okay. We will do this comparison, the elimination versus substitution reaction. When with the same type of reagent, we will go for elimination as well as substitution, and we'll see when the size is increasing, you are going to get the eliminated product. When your size is less, it will be substituted product. Okay, so if size is less, it will act as a nucleophile. If size is more or large, it will act as a base. So now what is happening here? This is the base. Now this negative charge, what it will do? It will not go for SN2 reaction. Rather, to take this negative charge will go and take one of this hydrogen, and that the bond will fall over here, and then this bromine will go out. Correct? So you are getting this alkene. Got it? So here the attacking reagent is this one, okay, as a base. But here the attacking reagent is this one, which is as a nucleophile, okay, OH minus, here C2H5, O minus. Got it? So this is the difference, correct? So this is again in the time of elimination versus substitution. See, this side it is having substitution reaction, this side it is happening elimination reaction, correct? So why I have discussed this? Because alcoholic KOH is first time it came for you, this alcoholic solution of potassium hydroxide. That's why I have discussed that what is the role of alcoholic KOH actually. So alcoholic means this alcohol word itself is having C2H5OH, and when you have this alcohol plus this KOH, what will happen? This will be potassium salt of potassium ethoxide, as well as you will get water. So this water will be there, remain in a mixture, but this will act as a base and it will pull one of the hydrogen. That is, we know that it's a beta hydrogen. It is beta hydrogen elimination. So this hydrogen it will take, and the bond will shift over here. At the same time, this bromine will go as a leaving group. Correct? Understood? Now in the next step, what is happening? Uh, we'll just discuss E1, E2, and E1CB, correct? So the elimination reaction. Okay, this is the elimination reaction. In this, we have E1, we have E2, and we have E1CB. Just we will discuss it over here only. So E1 means there will be a intermediate formation. Okay, I'll just write there will be an intermediate formation. Okay, like SN1. E2, there won't be any intermediate. Okay, E1CB, what will happen? Conjugation will be there. Okay, conjugation will be there. Okay, that intermediate will have conjugation. So now you see here the reactive intermediate will form, here nothing will form, here the conjugation it will form, correct? So we have to take the, as I told you, that it is depend fully upon the reagent as well as your starting material. So E1, when to follow the E1, if you have ethanol, CH3, CH2, and OH. Now this you are reacting with H2SO4. So from H2SO4 what you are getting? H plus. This is an electrophile. So now the lone pair will go and attract this electrophile. What is happening? CS through CH2 and OH2 plus. Because this will go and it will attach with this lone pair. And once it is going to attach with this lone pair, then oxygen will have 3 bond. And if oxygen is having 3 bond, what will happen? Here the positive charge will develop. And to remove this positivity at oxygen, what will happen? This bond will shift over here. As soon as this bond is shifting over here, you are going to get it. I'll just write it down like this, CH2 and one hydrogen below, because this is required next step. So it will be CH2 and here it will be plus charge, correct? And minus H2 I will write it here, water already removed. So see here the reactive intermediate we have formed, right? In the next step, now it will fall over here and you are going to get CH2 double bond CH2, but we are getting this reactive intermediate. So this is E1. Okay, it means like SN1, how we are telling that at the time only one substrate will be available. Okay, the order of reaction is first order reaction. Likewise here also you see the OH2, first it went off, you get the reactive intermediate, then the second one is going, right? So this is E1. Okay, now what about E2? So for E2 what we are going to get it, so the reagent starting material will change it over here, CH3, CH2, and we'll have this bromine. So we should have one good leaving group. Okay, what we should have? We should have one good leaving group. Now what is happening over here? See, we will use base over here. So I'll just write it down, CH2 and here one hydrogen. So see, reagent has changed. Here it's acid catalyzed, here it is base catalyzed, right? So this base will go and abstract this proton. As soon as this base is abstracting this proton, this bond will shift over here. If this bond is shifting over here, this bromine will go as a Br minus. Now what you are getting? CH2 double bond CH2. Now see, there is no in between intermediate, correct? It is like it is going and pulling this proton. As soon as it is taking the proton, the bond is shifting over here and this leaving group is leaving this place, correct? So you are getting alkene. Got it? So this will be E2, means simultaneously the things is happening, correct? For conjugated, so what you have to do it, this is CH2, then some maybe nitrile I'll put, or cyano, whatever, it is nitrile only. If one functional group is there, it will be nitrile. If more than one functional group is attached, then we call it cyano as per the IUPAC convention, correct? So here CH2 and we have Br. Now what will happen, you see, one hydrogen, I'll just write it down in below. So now base, see, this hydrogen is more acidic hydrogen because see this side it will pull, here the positivity will develop, this positivity it will ask from, like it will ask electron density from this carbon. If this carbon is providing, then what will happen, this carbon will have less electronegative like electron density, so what will happen, it will lose this proton and it will take back this negative charge, like the bonded pair of electron towards this carbon. Okay, that's why this is more acidic hydrogen. So now it will pull over here. So you can show it like the bond is shifting over here. As soon as the bond is shifting over here, this will move towards this place. So it will be N minus double bond carbon, carbon, okay, and then CH, then your CH2 and Br. Okay, and for this resonating structure, you can make it. So this is one structure. Second will be like it is moving over here and this is going here. So you will get N triple bond C, then carbon, then negative charge hydrogen CH2 Br. So this is contributing structure 2. Now if it is moving over here, it will move there. So that's the thing. This resonance will be continuing. Okay. Now what will happen? Suppose this is not moving here. Now the reaction, we have to carry the reaction, right? So now if this one is moving over here, this bond can directly shift over here. As soon as this bond is shifting over there, this bromine will go out. Correct? And then what you are getting the product? It will be N triple bond C, then here carbon double bond CH2. This is your product, here it's CH. So this is your product, this alkene, correct? Now you see what is the difference? Here it is, we have started with alcohol, here we started with alkyl halide, here we started with alkyl halide with one electron withdrawing group. Here it is acid catalyzed, it is base catalyzed, it is also base catalyzed. Here it is E1 means reactive intermediate is formation. Here E2 there is no reactive intermediate. Here in this the reactive intermediate form, that is carbanion, but it is conjugation, it is having conjugation. See, this we call conjugation. Okay, so conjugated base. Base, why it is base? Because negative charge is there, so negative means it can abstract a proton, so it will, we call it base. So this is elimination one, but as soon as but it is also a conjugated base. So because see the conjugation is there, so that's why these three difference you should know. Okay, this in competition they are going to ask you, correct? So I think you understood this elimination reaction and all the three types, E1, E2 and E1CB. Okay, so we'll write some point for elimination reaction. Okay, so elimination reaction, already we have written that it is a beta hydrogen elimination. Now it is according to Sedgwick rule. Okay, this is also a very nice rule, you should know this Sedgwick rule. In dehydrohalogenation okay reactions, the preferred product, the preferred product is that the preferred product is that alkane which has the greater number of alkyl group, greater number of alkyl group attached to the double bond, correct, double bonded carbon atom, correct. So similarly, I'll take alcoholic KOH. I'll take one example. This is your example, and with this example only, I will be trying to show you. I'll just put CH2, not this type of CH2. I'll take one hydrogen below because we have to remove this. Then CH, we have this leaving group over here, and then we have this CH3. So this also we will write it like that, CH2 and one carbon is on below because anyone can be withdrawn. Okay, now we have alcoholic KOH. This side also will take alcoholic KOH. Now we are getting two type of product. One product is CH3, CH double bond CH, CH3. Second type of product we are getting CH3, CH2, CH double bond CH2. Right? And you know the major product will be this one. Okay, 81% product we are getting this. Only 19% product we are getting this. So this is your major product and this is your minor product. How? See, both are alcoholic KOH, but we are getting two type of product. And now what Sedgep is saying, the alkyl group, see the alkene which has the greater number of alkyl group attached to the double bonded carbon atom. It means the more number of substitution present to the double bond, that will be your major product. See now, if this is the double bond, I'll use another color. If this is the double bond, this is the double bond. You see with this carbon, one hydrogen is attached and one CH3 is attached. For this carbon, one hydrogen, one CH3. It means this double bond is having two substituents. Okay, or two methyl group it is attached, or two alkyl groups. See, one alkyl group is this side, another alkyl group is this side. With this double bond, two alkyl group or two substituents is attached. Now for this, see this side only hydrogen is there. It means there is no alkyl group. Okay, there is no alkyl group, there is no substituents. But with this carbon, one alkyl group is attached, this one, correct? So we can say here only one substituent. Only one substituent or one alkyl group is attached. So here one alkyl group, here two alkyl group, and as per Sedgep rule, that alkane which has the greater number of alkyl group attached to the double bond carbon, which will be the major product, preferred product, right? So that's why this is a major product. But actually what is happening, why this is a major product and why these two substituents only we are taking? Let's see. This is alcoholic KOH. It means we have this base which is taking this proton, and it is, if it is going like this bromine will go out and you will fall this double bond over here. If suppose this base is taking this proton, if it is falling back, you are getting this double bond, right? But now where, like, so now for this, which one is deciding that whether this will be the major or this will be minor? Your hyperconjugation. Okay, hyperconjugation. See, here the hyperconjugation means the alpha carbon. You have to search the alpha carbon. With this double bond, we have two alpha carbon, and in this two alpha carbon, we have three hydrogen. It means total 6 hyperconjugating structure. Here we have only these two. It means two hyperconjugating structure, because one more is carbon. So carbon is will not play for the hyperconjugation. Only this hydrogen, it will, the alpha carbons hydrogen will play for a hyperconjugation, right? So here two hyperconjugation, here 6 hyperconjugation. So more stable one is this. That's why this is a major product. Okay. One more condition I'll give you with the alcoholic KOH. I'll just take tertiary butoxide. Okay. There the Sedgep rule will fail. Okay. See CH3, CH, hydrogen I'll put it over, CH, Br and CH2 hydrogen. The same structure, right? Yes. Now if I'm taking tertiary butoxide, okay, alcohol, tertiary butyl alcohol reacting with your, or we can simply write alcoholic or tertiary butyl alcohol with potassium hydroxide. So you will get this as a base. So now see this tertiary butyl alcohol or butoxide, how it will look? It will look like this: CH3, carbon, CH3, CH3, O minus, and then K plus. It means it's a bulky base. See, it's a more bulkier than your CH3, CH2, O minus. See, this is the size, and here see the size. So now what will happen? You are going to get only single product: CH3, CH2, CH, double bond, CH2. You are not going to get this more substituted double bond, what we have wrote over here. This one you are not going to get it with that reagent. Okay, it means Now you will think that I have to remember all the reagents. No, it's not required. See, this is a smaller reagent, so it can attack over to this carbon, this hydrogen also. It can attack over this hydrogen also. Now you have to see the hyperconjugation. Based on hyperconjugation, you are saying that this will be the major product because it's having 6 hyperconjugating structure. But in this case, this is a bulkier base. It can't go here. The negative charge can't approach this hydrogen. Why? Because it is in between. Okay, the molecule what you are seeing as a linear, it is not linear. It will be like 2, 3, 4. It is like this. So if your bromine is attached over here, so see, right, your hydrogen. So how it will approach? It can't approach the bigger one. The bigger one can approach only to this uh, the ending part or this ending part. It can't operate towards your middle part. Okay, it will only having access to your ending part. So now see this ending, this hydrogen is not acidic, so it won't pull this hydrogen. If you are pulling this hydrogen, it won't shift over here, because if it is shifting over here, nothing is there to this carbon for living, like no, nothing is there to leave this carbon, right? So what we have to do, we have to take that hydrogen where the hydrogen is more acidic. So here only two hydrogen, this hydrogen and this hydrogen is acidic. So now this is not possible because it is in between, middle. So now it's having only one option. It can pull only this hydrogen. If it is pulling this hydrogen, then this bond will shift over here and the leaving group will go out. So you are getting this as a 100% product, and this is not your Sedgwick product, correct? We call it Hofmann product. Understood? We call it Hofmann product, right? So I hope you understood the elimination reaction. Okay. Next we will do the reaction with metal. Okay. Next we'll do reaction with metal. So see, if you are liking the classes, please do subscribe and like it. So I can understand that, okay, you are liking. So I will give, as I told you that I will give you the lengthier classes and your syllabus will be completing very soon. But if you are not liking and subscribing, that it will be difficult for me, right? Because for my motivation, your liking and subscribing is my motivation. So please do like and subscribe if you are really liking. If you are not liking, please do put unlike. Okay, so that in that way I will modify my way of teaching, correct? So thank you for the class.